Before we can talk about a semiconductor, first we need to know about a conductor and an insulator. A conductor, as its name implies, is a substance that conducts electricity. In order to conduct electricity, electrons need to move around because protons and neutrons are bound in the atomic nuclei. The electrons in the outermost shell of an atom are called valence electrons. Now, these valence electrons in a series of energy level form an energy band called a valence band. From the valence band, electrons can jump into an empty band of electron orbitals called a conduction band. In a conductor, there is no gap between the valence band and the conduction band. Electrons can freely move from the valence band to the conduction band. This movement of electrons creates an electric current and conducts electricity. An insulator, on the other hand, is a substance that does not conduct electricity. Unlike conductors, insulators have a large gap between the valence band and the conduction band. Valence electrons cannot reach the conduction band, therefore, no electricity flows. Finally, let's talk about a semiconductor. A semiconductor is a substance that has properties between an insulator and a conductor. There is a gap between the valence and the conduction bands. However, it is small enough so that the valence electrons can reach the conduction band when the energy is provided by an applied voltage. The most widely used semiconductor material is the silicon, hence the name Silicon Valley in California. Silicon atom has 4 valence electrons, so each silicon atom can bind to 4 other silicon atoms. This way, all of the valence electrons are used to make a bond with other silicon and they cannot move around. Now, this makes a pure silicon crystal an insulator rather than a conductor. To increase conductivity of silicon, tiny amounts of impurities can be added before silicon crystallization. Now, this process is called doping. Depending on the impurity that's introduced to silicon, it can be classified as N-type semiconductor or P-type semiconductor. If an impurity atom has 5 valence electrons, such as phosphorus, 4 valence electrons can bond with 4 adjacent silicon atoms, and the 5th electron has nothing to bind to, so it's free to move around. This creates extra electron energy levels. Now, electrons can easily jump into the conduction band when the energy is provided by an applied voltage. This is called N-type semiconductor. N-type refers to the negative charge of the extra electron. If an impurity atom has 3 valence electrons, such as boron, it then binds with 3 adjacent silicon atoms and forms a hole where the electron of the 4th silicon has nothing to bind to. The absence of an electron creates a positive charge. This positive charge can move from atom to atom as electrons leave their positions. Electrons from the valence band can be elevated to extra hole energy levels when the energy is provided, once again, by an applied voltage. This is called P-type semiconductor. P-type refers to the positive charge due to the missing electrons. So where do we use semiconductors? Semiconductors are the best material to use in many electrical circuits where we have to control the electron flow, such as in a temperature sensor. Many electrical appliances in everyday life use semiconductors as well, of course. Examples include laptops, smartphones, televisions, washing machines,